Yeah, I think, yeah, it started recording. So this is first of a few more talks to come. This is a new thing that we're trying out, trying to get our alumni or even just interesting talks uh, based on programming, more or less. The first one of the series will have Sudhakar. Sudhakar is a security researcher and a CTF veteran. He'll be here to talk to you about general cybersecurity and as well as other stuff that deems that is interesting. So yeah, I guess we'll start off with this. So Sudhakar, do you want to introduce yourself? Probably say some more stuff.
Yeah, hi guys. Good evening. I am Sudhakar. I passed out in 2017, computer science. I have been working in the cybersecurity industry since. So it has been like 3 years now. Uh, Mostly, I got into security by playing CTFs in college. So when I was in college, Microsoft used to conduct this CTF called Build the Shield, and which was very exclusive to all the IITs and NITs, I think. So they mailed up the Gymkhana saying that we are conducting this. Can you forward this into the institute? So that's when I know what, like, I got to know what a CTF is, and then I started playing. I was kind of interested in security, but I was like moving aimlessly for a while of not knowing what to do and how to approach cybersecurity as a career or what to do to get better at it. So CTFs were the way where I tried like started by playing some CTFs, not knowing anything, learning on like playing CTFs. Then by the end of it, when I was in fourth year, I interviewed for a couple of places. I did not want to get into dev, so one of them was pretty handy. Like the knowledge that I had collected during CTFs was very uh, helpful for clearing that interview. And based on what the write-ups I have written or the techniques that I have learned in that CTF time, I was able to clear that interview. I got a couple of offers. I joined one which was pretty relaxed and research-based job. It was in Pune, so it's called Payatu. It's a very small company, around 30-35 people, but the job was vulnerability research. The job is that take popular softwares, let's say whatever you use, Chrome, Adobe PDF readers, uh, popular browsers as Safari, Firefox, or other PDF or document parsers, Microsoft Office. So choose a target of that level, try to find out bugs that can be converted into exploits on a larger scale with a good support. So that was kind of the job that I had there. It included a lot of things like doing static analysis, reading a lot of code, finding the code pattern for vulnerabilities, learning about the vulnerabilities specific to C, C++, and memory corruption, then fuzzing, trying to uh, generate input for these applications such that they crash with a memory corruption exception or something like that, and then writing or figuring out an exploit from that point of time. So I did that for quite a while. I recently switched to another role at a EDR company, so it's called CrowdStrike. So EDR is endpoint detection and response, so in which whatever place that you work in, your the company provided laptop or desktop will have a software that will look for intrusions or some kind of behavioral patterns based on what is being executed on your machine, and try to figure out if you were attacked at a point of time or not, and try to detect that and like not allow the malware to execute on your machine. So it's a pretty powerful like ML powered product that they have, and I'm in one of the teams which is which like does that. So that's that. So that's where I'm currently working right now. It has been 3 months here. If you have any questions on the type of work that I did in both of these companies, I'll be happy to answer.
Yeah, I guess we'll come to that, Sudhakar. But there are a lot of juniors here who want to get started in the field of CTF. So, how would you like? What would be your recommendation on what's the best way to get started and get build up their interest in the field of security and such?
So the best way that I would say is do not skip. Like, let's say most of the CTFs are run on weekends, so try to be persistent. Even if you don't know anything, you can't figure out any challenge or how the challenge is made or how it is getting solved or how other people solved it. You should even then spend time on that challenge for a while. So there's a great website, ctftime.org. Follow that. Import the calendar into your Google Calendar so that you have a knowledge of what CTFs are over the weekend and which one of them are better based on the ratings that are there on CTF Time. Then choose a category that you like. Let's say you are into hacking websites and figuring out stuff in like the website, then you can try that category. If you are into cryptography and like math stuff, if you like that, maybe competitive coding people would like that, so you can try the crypto category. Other than that, there's reversing and binary exploitation. So if you're into low level stuff, assembly and memory corruption and exploits, so you can try there. So based on this, try to find a category that fits. So if you are a newbie, I would definitely say go with web, because that gives you some sort of like there's a lot of resources on web, so you can just go read bug bounty write-ups and all, so to figure out what's happening. Once you have some like attacker mindset of how to do things, how to tackle a challenge, or how to attack a particular website, then I would say you can move on to binary analysis and all that, because that mindset is what drives you eventually. So do that. So once that is done, let's say I was playing a CTF this weekend on Sunday, but I did not solve any challenge. So what I'll do is over the week, then I'll try to replicate the write-ups that are published. So ctftime.org is still like they have a list of the challenges from the CTF, and you can just go and read the write up. It will be pretty technical. Try to reproduce that. Try to see what the author is trying to do. If there are multiple write ups, look at all the different approaches that everybody used. And this pretty much gives you the practice of doing the same what the write up author did. So over a period of time, not just like couple of weeks, or a period of time, 4 or 5 months, you will develop that skill to recognize a challenge or the type of vulnerability that's there. Use your past knowledge or experience in the CTFs, or from reading the write-ups or practicing challenges from open CTFs. Then you would be able to like figure out a normal challenge. So in my case, when I was in college, I think second year, uh, it was not that the number of CTs were not that frequent at that point. But I still so what I did was I got a classmate and a couple of seniors from 2016 batch, and we tried to play every weekend. So what we did was, once we know that we are going to participate in Microsoft Build the Shield, we used to sit in the library, four of us, trying to figure out challenges even if we don't understand things. So in the first CTF, we could not even solve the trivia challenge. So trivia is just like a general knowledge question. We couldn't even solve that. But slowly we tried to build up. So there were four people in the team. One was BKC, Bhomakanti, Krishna Chaitanya. There was Harsh Mohan. There was one of my classmates, Himanshu. So eventually, when we were reading other write-ups, some people were more comfortable with web. Some were more comfortable with the low-level part. So people tried to work on that. Everybody decided what they will work on. So crypto was something which I think everyone was good at, because mostly it was maths and stuff. Then web was very good for Harsh Mohan and BKC. There was forensics, in which Harsh Mohan was very good at. So there were different of like number of different categories which everybody tried to master. And like easy level challenges should be like, if you are okay enough, then you should be able to solve easy challenges in almost all the categories. And whatever category that you prefer, you should be able to go to medium or hard, let's say, over practice of 1 year or something like that. So that's how basically persistence, doing the write-ups again and again, and just that, like playing multiple CTFs, even if you don't have like time, maybe give a couple of hours to just one challenge, not like n challenges. Just pick up one, try to solve it. If you don't, just read the write-up. So that's what I did all the time. So I usually skipped college on Mondays, and I tried to replicate whatever I did over the weekend on Monday, and try to figure out, have some notes ready in my laptop which I can later refer to and all. So you there?
Oh yeah. Think. Yeah. Never mind. So, would you like to, like, just describe some of the differences how a security researcher job would be different from, say, software developer or something like that?
Yeah, so I interned at Amazon as a software development engineer. So while I was there, I was given, so at that point, Amazon was moving from the legacy systems to their own internal AWS services. So instead of Oracle DB, they were trying to move into DynamoDB and stuff. So while in that role, I was given a very specific module to write. So that means my manager set up a job that, okay, this is the module that you have to write, these are the features that he gave me on the week one, and he said, I want you to come up with this, and eventually over a period of 2 months you have to figure out all the stuff. Maybe if you're not comfortable with the language, try to get comfortable with it, with the framework, the team and all that, and eventually you get to a point where there were a couple of requirements that your manager or somebody in the team set for you. Your code meets that criteria, and you have a pretty set job, like you have a very standard approach of trying to solve problems and all. So that was my experience with Amazon. But in a security researcher role, it's more like you can say PhD's job. So you don't have set guidelines, you don't have those references or something that you will deliver at end point of time. What you do is, what you instead try to figure out, like creative ways to solve a problem. So let's say at one point I was looking at Internet Explorer and how to attack that browser, or how to compromise someone who is browsing using Internet Explorer, although nobody does that. So what I would do in that case is, there are a couple of things that I would do. First is something called attack surface analysis. So in that, what I would do is I'll open that software. So if it's a PDF reader, I know if it's a PDF reader, what does a PDF look like? Is it a binary file? Is it a text file? Does it have a grammar? By grammar, I mean, does it have a language like you have in C, C++, JavaScript and all that? So does it follow that standard? Is that standard open sourced? Can I read upon it? How do I, if I have a PDF, how do I validate that PDF is correct or not, and stuff like that. So basically you start by building from there, learning about the target, looking at what the target is doing for that file. So there are a couple of tools called, so in case if you have source code of the target, you can maybe put that in a debugger and then look at the behavior, what the target software is doing for your input. If it's Chrome or Firefox or Safari, you can build it with source, not Chromium and not Safari. There's a WebKit that is open source for that. So you can build those and try to debug that under your GNU debugger or whatever debugger that you prefer in Windows or Linux, whatever. And then try to see or understand how the data flow is happening, how the control flow is happening, what are the different classes of objects that are getting passed, what are their properties, what are their relations. So basically build some knowledge around that. So at this point of time, when I was in my last role at Payatu, we did not have those guidelines. So in Amazon, they would say that, okay, I want by end of this week, for you to complete this part of the API so that we can have some security review on it. But in case of Payato, it was not like that. So it was mostly like we will meet over every Monday and we'll discuss what are the techniques that I'm going to use this week to figure out or to find out a new attack surface, how I'm going to generate test cases for that. So if it's a PDF, can I generate valid or invalid PDFs that Adobe Reader can parse? If it's an HTML file, can I generate regular HTML content that my browser, when opens, crashes the file? Or if it's not that, so that's something called fuzzing. If it's not that, it could be how much source code have I read from that project and how much knowledge I have gained. Or if it's a binary file, let's say Internet Explorer, which we don't have the source of, how much part of it I have reversed, and the same, how much knowledge base have I made. So there was no set you can say milestones that I did every weekend or week, and like it was pretty open ended. So if you are creative, if you have that attacker mindset of trying to solve tacky problems which like are not that standard, you should try doing that. But if you like to develop softwares, and there is also a good the payment thing is the pay is also great. So both of these won't differ there. So if you it basically depends on your mindset, that if you like to develop softwares and if you like to solve hard problems, you can even choose software engineering. But if you like to solve hard problems into security with an attacker mindset, you should go with security researcher or something like that role.
Just
Sudhakar, have
to play
you?
off,
Okay, go on.
okay, yeah. Just to play off that, what if you both like dev as well as the security, the the what do you say, the dopamine hit that you get when you find a new security vulnerability or something like that. I am speaking from my perspective. I am someone who likes both dev as well as the security stuff. So what would you say to someone like that?
So it's not like if you're a security researcher, you won't be developing anything. Dev is a core job of being a security researcher, because you'll be reading code most of the time or figuring something out, or you'll be building tools that you or somebody in your team, or if you open source it, everybody in the world can use. So at my current last workplace, I was like dev around 40% of the times. But what you said essentially, that dopamine hit of trying to figure out a vulnerability, or when your exploit works finally, that's a great hit. So in my case also, when I have something like that, it's euphoric. I feel that for quite a time. Then I try to redo it and maybe replicate it over a period of time and try to figure out quirks and all. So yeah, that's kind of one reason that I started doing this, because when you solve that CTF challenge, when you submit that flag, you get that hit. And similarly, when you figure out a vulnerability or you write an exploit that's like 100% working all the time, then it's the same euphoric feel that I like. So that's like one of the driving reasons that I do.
Yeah, got it. Digant, you can ask your whatever you were going to ask.
That was my question actually. So,
Okay, that's great. Yeah, so I wanted to ask about the cybersecurity opportunities, like career opportunities in India specifically, because that's what a lot of us are going for, I guess. So, what do you have to say about that?
So there are multiple companies that when you are trying to approach as a full-time employment scene, then there are multiple companies. So similar to CrowdStrike, there are other EDR solutions. There's McAfee, there's FireEye, there's Kaspersky. So they hire very easily from IITs. So if you are looking for a role which is primarily into a security company, or maybe you want to figure out that yeah, I'll try to look at this role and maybe switch into another team in that company which will be more security centric, you can do that. So you can get hired as a developer very easily into FireEye or McAfee, and when I think the 18 months are passed, you can try other teams or something like that. So based on how it's going. So that's like one of the easy entryway into these companies. Other than this, so most of the companies, they prefer veterans over entry level people from college. So in a security researcher role is what I think, because I haven't seen that in India that often. Other things that we have are the pen testers and red team kind of role. So what pen tester does is, so your company or the team that you work for, if it's some internal tool, let's say I worked at Amazon, there was an internal team that looked at the source code of your product or the software that was deployed the inside Amazon, or if it's facing the internet, they will look at the vulnerabilities, find out, and tell it to your team. So similarly, it's a pen testing job. So you will be given a target. So it could be a network, it could be some company's website, it could be a mobile application, it could be an application running on your Windows or Linux machine. And as a part of the team, you'll have to find out weaknesses in that app. So you can do that. So it's one of the most popular uh, security roles in India. There are a lot of companies for this, and they are even they easily hire people who are new to security, because this job role can be easily moderated or let's say mentored. So this one is quite popular. Even in my last role, there was a complete team of pen testers that you can try. So in that role, similar to what we have in CTFs, it could be a website, it could be an application, you can reverse it. Maybe it could be a mobile application. You can figure out what kind of data it is storing, where it's storing, what is the level of encryption, is there any weakness. So that's like pretty standard pen tester role when you get into it. And then there's this red teaming role in which you can do the physical security and social engineering part. So in a red teamer role, what you usually do is you are given knowledge about a particular campus of a company located at X address. You go there as an attacker, try to figure out ways into getting into that campus, maybe lockpicking, tailgating, or whatever, then trying to compromise the client's network by social engineering, fooling people to let them give access to their machine to you, and then trying to plant malware on that device. So that is one red team exercise that people do. So that is also one of the options that people can choose. So yeah, so these are the standard roles that you have. Other than that, security researcher roles are very rarely given. There are a couple of startups that have started doing this right now. But what they would want you to have is a good experience with the CTFs, a good uh, popular blog or something like that, for you to have a good profile for them to hire you.
Okay, that's great. Uh, yeah, I wanted to ask how easy is it? Like most of the jobs for undergrads are usually dev related. So there is usually some stigma around specific niches of tech. Like if you choose one, you probably can't go into the other. Like there is stigma like that. So how much of that is prevalent in cybersecurity? Like how would a developer switch to cybersecurity? How easy is it for him to do that?
Uh, Depending on, let's say, what team you are a member of, let's say you join a team that basically writes C++ all the time, and you have, like, you are proficient with it, then you understand the constructs that lead to vulnerabilities within C++. So if you are later then trying to switch into a role which which tries to break C++ softwares or popular softwares like such, that would be a great plus. So other than this, what I would want is that when you are dev, you have to show some knowledge or initiative towards security, because maybe in your personal time you try to figure out what the current state of research is, what people are doing around the world, how are they figuring out things, what are the current state of vulnerabilities. If you have a couple of two of your own, that would be pretty great. You will be easily hired into security roles. So if the company is huge, you can internally transfer very easily. That does not give you the hassle of like interviewing again and going through all the processes, joining a new company with new roles and all that. So that's why I said that you can join as a developer, try to show some initiative and switch into a more security centric role, because that's an easier way for you, of not like, let's say if I change the company, I would have to change the faces of people which I currently live with. I'll probably have to move from different cities and all that. So that like lessens the hassle. So once you are comfortable in the second role as a security centric role in the current company that you work with, maybe later a couple of years or another year, you could try giving big shots a try and go into a more security researcher type of role.
Okay, that's great. That clears it up. Along the same lines, how are the interviews for cybersecurity firms, given that you have worked with two of them?
Yeah, so they are quite challenging and technical. So I have not just interviewed for these two places. I have interviewed for the very large teams. I have interviewed for Google security team. I have interviewed for there's a Cisco Talos security team that's pretty like big. So I've interviewed for both of these places. So one of the main challenges is that they would give you a like semi medium hard exercise that you'll have to do. It will be like a CTF. So they might give you a binary. So if I'm a security researcher looking for bugs, then I should be able to do it in a binary that they give. So that's pretty common is what I have seen. Other than that, there might be a couple of rounds of interviews with people who are actually hands on. So they might ask, so let's say I currently work at some place, or I am just graduating out of college, and then they ask you what is the sort of vulnerabilities that you have worked on. Then you might say, okay, I have looked into XSS on Google's website. This is what I found. Then they would keep asking you around that situation, maybe add more trickier challenges to the problem, and just look at you figuring out solutions to it. So apart from CTFs, there will be like couple of rounds. So in case of Cisco Talos, I had 11 rounds, and in case of Google, I had 5 rounds. So all of them were pretty technical and very deeply involved into the concepts that I usually worked around. So that those are like more prominent teams, and they also wanted somebody who had experience. So that is what I expect. But for an entry level person joining the team, they would still want you to solve a challenge. So in the current place that I work, I have looked at the hiring policy of a similar role of a security researcher. I have seen people giving them malware as a interview task. So they will give you a malware and they will ask you to look at that malware, analyze the behavior, what sort of stuff it is doing, how do you detect the presence of this malware in your machine and stuff like that. So I've seen that also here. So these are some kind of examples that I have seen people giving to the interviewees during interview or before an interview. So in Cisco, they gave me HTTPD binary that they ran. It had a couple of bugs. There's something called uh, I don't know. I don't remember RFI. So remote file inclusion was there. There was path. So there was a parsing bug in the path of the page that you're trying to open. So there are a couple of bugs. So they were pretty standard. Apart from this, there was a heap use after free bug. And yeah, that's pretty much it. And in case of Payato, I was not giving any challenge, but they actually he actually like gave me buggy code. So he pasted my interviewer pasted some 50 lines of code in the text pad that we were sharing, and he asked me what sort of buggy code you see here, what could be a result of this buggy code, how can you exploit this vulnerability, what how do you patch this vulnerability, how critical do you think it is, given on a score of 1 to 10. He would ask you to rate it and something like that. So that was my experience in some places that I have seen.
Okay, that's great. I guess we can look at some questions from the audience.
I have one question. What's the basic difference that you'll say between solving problems on a CTF versus solving real-world cybersecurity problems? Finding problems on a real-world product or a website.
Yeah, so in case of a CTF, you definitely know that there's a bug, and you have that 2 hours or 20 hours or 48 hours that you have a timeline, and you know there's a bug because other people are doing it. You find out that bug and you exploit it. They're also very specific. So let's say if I take if I take a binary exploitation challenge, the binary is pretty small, maybe around, let's say, 20-30 kbs. The code is not that huge. Or if it's a prominent challenge, if they're giving you a browser hacking challenge, then also they tell you the CVE that okay, we are targeting this, or they might give you their patch that they've used to patch that browser. So the point boils down to that mentality that when you are targeting a real world application, it could be pretty huge. So with my course at Payatu, there was a very specific DLL. DLL is a library in Windows for an executable. So I spent around 2 complete months just reversing that DLL, looking into the data structures that it has internally, naming all of the fields of the classes that it has, the structures that it has, trying to parse out every logic that I can derive from it and build knowledge base around it. So if I knew that, so if that similar DLL was given to me in a challenge and I had to solve it in 24 hours, I would have known that yeah, there's a bug. But in the real world software, I did not know. It took me around 3 months to figure out that yeah, actually there was a bug. So it, like, there's a change in mentality that when you approach a problem in CTF and you approach a real world problem. And then there are the techniques and all that, because what I feel like in CTFs is once you get to that point that you have some knowledge of almost like 80% of the types of attack that are present. So it does not reflect that great into real world bugs that are there, because new categories of attacks and attack vectors are found very frequently. And since everybody in the world is attacking that target, that makes this a very highly like edged competition, because everybody is finding a bug, and at some point of time you will be uh, out of that race if you don't try to adapt.
Yeah. Uh, we can look at some questions from the audience. So someone was asking, as someone who was just starting out, should I be using Kali and all its tools from the get-go?
Yeah, so yeah, Kali is a pretty good OS, but even I used it in college. But after some point of time, you would find out that 99% of the tools that are there in Kali are not needed in CTFs. So in case if you are trying out a web challenge, all you need is burp suite. In case you are trying to solve out, let's say, cryptography challenge, then all you need is a Python installation, or maybe Sage Math in some cases. If you're trying out binary exploitation and reversing challenge, all you need is a disassembler and decompilers. It's Radar 2 or Cutter or IDA Pro, and just Python installation. So if you're trying to get into CTFs, there are not that many tools that you would need per se. So installing Kali would be an overkill, unless you are trying to figure out the tools that are there, or trying to build out a tool of your own of a problem that you see out there in the world. So if you're doing that, I guess that is okay. But if you're trying to just play CTFs and learn around the CTF, then I don't think Kali would be that great of a choice. I think you can just try Ubuntu 18, 19, or 20, whatever that suits your machine, and then just go around with it. There will be, I think, I have a script which gets my Ubuntu Docker ready. It has a couple of installation of installing GDB, GCC, Radar 2, and that's it. Yeah, that's pretty much what I use. So there's not a lot of tools that I use, or even after some point of time, you will be saying that okay, in my Kali installation, I have not used this subdomain lister tool. So if you're doing bug bounty or something like that, if you're trying to like attack real targets which are under scope of a bounty program, I think that would be the domain lister tool would be a good plus. But in case of a normal CTF, it won't be, because they would pretty specifically say to you that, okay, this is the website of the vulnerable website, this is the IP of the vulnerable website, just attack this platform, don't go anywhere out of it. So you don't have to do reconnaissance of that sort, that iterating over all the IP space of that company and all. So you don't need that amount of tools. That is that what I want to say.
Yeah, that sounds great. Someone wanted to know what kind of problem statements are in CTF. I know you've you discussed this once, but I think some people have trickled in after that. So maybe if you could repeat that, it would be great.
Yeah, so guys, there are like 5-6 categories in total. So one of the most popular is web. So in this web category, the challenge author will build a website. They will have some sort of bug, maybe in the server input logic, or how the queries are getting executed in the database. That would eventually, like, somebody who visits the website can try to figure that out and attack the server. So the all of these challenges, the final point is to get the flag. So flag will be a string that will have a pattern of some sort, that you will see. When you see, you will know, yeah, this is the flag. So when you visit that website, try to browse around, find out, okay, what is not standard, how is it buggy and stuff like that. So all the popular web attack techniques, SQL injection, LFI, RFI, and all that. So there's even parameter injection. There's a lot of it. So I am not like, I don't know the recent where the current state of web security research is, but you'll have to know that to figure out and look for all of this in the website. So that is like one category, that is web. Next, there's a crypto category. So in crypto, the author might have a crypto system of their own. So they might build up a new crypto system, let's say something around RSA, or something not even remotely similar to RSA. It could be a completely custom made crypto system. So they'll give you a script, or they might run a server on the remote side that you can connect to, and they might give you the service of encrypting or decrypting some text, or decrypting the ciphertext. So based on that, you might be given server.py or server.perl or whatever, that you can then read the source code, try to figure out the maths behind that server logic, the server crypto logic, and try to find out weaknesses in it. So that is pretty like, for me that was very good, because most of the teammates that were there, they were pretty math centric, and we could discuss math based problems there and we could solve it. So yeah, crypto was a very big plus in that case. The next one is something called reversing. So in case of reverse, it's called reverse engineering, in which they give you a binary. So if you are so let's say, in your Linux you run that ls command, or you run cat etc password, something like that. So cat is actually a binary that is running on your machine. It's an elf file. So similarly, the CTF challenge author will give you ELF or an exe. Exe is something which runs on Windows, or there'll be a Mac file that is from the Mac, or whatever, something like that. So something that runs somewhere. It could also be a Python file, not just a binary executable. So what it will have, it might have a checking logic. So something like, I run that binary, it says that give me the flag, and it reads that flag from std input, and then verifies that, yeah, whatever input that you gave is actually the flag or not. So that's like one very simple case of a reverse engineering problem, in which they just take the input, verify if it's the flag or not, and then they tell you that, okay, yeah, this is not the flag. So you'll have to reverse that executable in a disassembler by reading the assembly, or use a decompiler to read sudo c code and then understand the control flow and where the verification is getting executed, how can you get it to pass and all that. So that's one, like, that's a reverse engineering. Then there's binary exploitation, or it's called pawn in most of the CTFs, in which they give you an executable or whatever, a service that is running on the remote server. Excuse me. So they will also have a vulnerability present in that service, so that when you connect and interact with that server binary, you find out, yeah, there's a stack buffer overflow that I can overflow, and then try to attack it with by overriding the instruction pointer, getting it to execute shellcode or something like that. So that's one category. Other than this, there are a number of miscellaneous categories, including forensics. So forensics is one. They might give you a dump of the disk, or they might give you a pcap or something like that, that you normally have in a forensics way of analyzing things. So it might be possible that somebody was listening to the traffic when the attacker was talking to the control and command server. So you have that traffic. Can you figure out the credentials to attacker or something like that? So yeah, forensics is there. Then there are a number of miscellaneous categories. They might involve machine learning in some sort, or there might even be programming challenges. They might give you a maze and try say that, okay, you want to solve this maze or something like that. Yeah, so that's pretty much all the categories that there is. If I missed something, it's called stegano. So steganography, it used to be present in old CTFs, in which they will hide the flag. By hide, I mean some insane logic that they will use to hide that flag somewhere in some file that you have to figure out. So those are the like least favorite categories of mine, both steganography and forensics. And I don't see them pretty often right now in CTFs also. So most of the popular ones, web cryptography, reversing, and binary exploitation is all I see right now in popular in CTFs.
Yeah, that was a great introduction to CTFs. I wanted to ask, what's the importance of higher studies in cybersecurity field?
Yeah, so I would definitely recommend people getting into higher studies, mostly in Europe or US, because we don't have that many roles of the like target role that I'm trying to follow in India right now. So if you get into a good institute in US or Europe, I would say you should definitely pursue that, because getting hired into a security team from a master's degree or a PhD is very easy. And similar, the demographic of being in US would give you the plus of getting into a security team at, let's say, Facebook, Google, or the other popular security teams that we have, even in case of CrowdStrike or McAfee or Kaspersky and all that. So once you are pretty decent, so you can choose a security specialization for your masters, and you can get into easily, because in India the bachelor's is not that pretty specific to security. So most of the companies don't like usually hire from this, apart from the normal developers that we have in a product based company.
Yeah, one of the audience wants to know what tools do you generally use for the purpose of binary exploitation, I believe.
Yeah, so first is to read code. I use Vim and C tags. Then sometimes I also use VS Code a lot, because I write code in there. And so that also gets integrated with C tags and everything. So that is the main code reading thing that I do. Earlier I used to use C Lion. It was also pretty good. So this was for reading code. For debugger, I use GDB, which is an LLDB in Mac and GDB in your normal Linux systems. There are a couple of scripts that are there online that give a better output for GDB. So JFPDA and PondDBG and all that. Then for reversing, I use IDA Pro. So both my current role and in my last role, I had access to IDA Pro. Uh, or sometimes I use, if I am doing something for personal reasons, I might use Radare 2, because if I want to script something from the terminal, basically, then I can use Radare 2. So these are all the tools that I mostly use. It was a pretty short list, yeah.
Yeah, that's great. I think Sarthak wants to ask something. Sarthak, you can go ahead.
Yeah, so like someone starting out in security, so there is some kind of a thinking that CP is just important for a job. So can we have like a motivation to starting with security? Because I asked many people, they say that the course is a lot. Like someone starting with the binary has to know what is assembly, and then what how binaries work, and then we'll go to vulnerabilities and stuff. So like most of the people ignore this because they know that they'll do CP and they'll get a job. So how do one keep when someone keeps himself motivated for doing this thing?
So I will still say that doing CP is actually important because uh, as a security, so sometimes the roles that you are offered, it could be a security engineer role. So in case of Google, when I applied, they actually gave me 4 interviews of the your normal DP and graph problems. So getting that, like having that, is a pretty decent plus. So this is what even my senior told me when I was in first year. So I told him that I wanted to get into security. He told me you should at least do CP because most of the interviews revolve around what you have learned in college, and I think not like dedicated to doing CP, but having that little knowledge of when a problem can be solved by DP and what strategy to choose, or even practicing on lead code or something like that. So you should definitely give that a try. It also gives you some edge or sometimes over other CTF players because some challenges usually require uh, very hard challenges sometimes required problems that were not like I could not even understand them. But when I like learned some CP and I figured, okay, yeah, this was one of the things that I could have tried as a solution. So what I would definitely say that you should give CP a try, and you should always have a backup offer, maybe from college placement or something like that, because uh, state of getting a security based role in India is very hard. So this was also the same thing that I had. So I had a backup offer from Amazon just in case, so I don't get into any of the security companies that I had applied into. So other than that, yeah, so what you said is essentially true. You have to, if you are trying to target binary exploitation or something like that, there's a lot of stuff that you'll have to get used to and have it in mind very frequently before you, like the learning curve is pretty steep. Once you get to that point that it is getting functionally useful to you, it would take you a lot of time and effort. While in case of CP, you can do code like code forces ABC once you practice for around, let's say, 6 months or 12 months, something like that. So in that case, yeah, matlab, it's kind of a trade-off. It also, as I started when I started like when I started with this talk, I said that dedication is one thing that you should always follow. So you should always keep that uh, urge of letting into harder problems and trying to solve problems that you haven't seen before. So that is also what CP's motto is. So as I said, even if you don't solve a challenge similar to CP, if you don't solve a problem, let's say problem B, and you at least read that write up, and next time you see it, you could solve it. So that's pretty much same. But what I would say is, as a beginner, you should not target binary exploitation, is what I feel. Because first, you should develop that mindset of being an attacker, is what pretty much helps you later or drives you later when you are doing such challenges. Was I like, I think I went off of your point for a little bit. Is that okay?
Yeah, fine, fine. Sure.
Okay, hi. Hi everyone. So I wanted to ask something. So you have been in this field, the cybersecurity field for a long time now, and I wanted to ask, how do you feel about this thing? Like some kind of feedback. Like how will you rate your journey in this field?
So when I got into my last role from college, most of the things that I learned, so there's this something called fuzzing, in which you generate some sort of input to the target program and you see if it crashes, and if that crash is somewhere related to a memory corruption. So this is something called fuzzing. So I did not have any knowledge on this topic in college, and the job that I took was mostly doing development work around fuzzing. And Yeah, so that was pretty much the role. So when I came here, we started by writing a fuzzer from scratch. So that was a pretty good experience. I learned a lot from the current, like whatever senior I had in the team. There was just one. So we found out a number of strategies that we could use to fuzz different applications. I started reversing actually like professionally. So that means whatever you do, you keep knowledge base of the past work that you have done, not like solving CTFs, you don't have any knowledge base of any binary that you have worked on earlier. So the projects were larger. I found out like scripting in larger binaries in case of IDA Pro or something like that. I learned that. So that was a pretty plus. But after some time, when you choose harder challenges, let's say I chose Chrome, Google Chrome for around 1 year back, but the target is so high, it's so hard, like everybody's trying to attack it. There are not a number of bugs that are coming that frequently now because Chrome internal team themselves is pretty good on trying to attack that software. They fuzz it internally. Google has a better infrastructure than what I can afford. So that was the problem, like that was a problem that I like to solve. But over a point of time, I did not find any creative solutions that led to a crash or a vulnerability in that software. So this got me pretty burnt up, you can say, because I was not getting positive results, and we tried a lot of techniques that we were working around. So that is what like comes up with the research profile that you choose. Sometimes your research passes, sometimes it doesn't. Sometimes you get bugs or you find out vulnerability, sometimes you don't. So yeah, so it was a mix of all that. You But eventually I learned a lot from what I got from this experience. I learned a lot of strategies, what to choose where. I Right now I know how many strategies would fail and sometimes what could succeed. So this was mostly what. So I have been in 3 years for the same company in my last role. So yeah, it was kind of a roller coaster all the time. Sometimes we found bugs, sometimes we didn't. We could go on dry for 6 7 months. We could be looking at new target. That new target could take us like couple of months to actually get to know about it. But the team was good, the seniors were good, the management was good, so the learning process was quite great there. So I would rate it around 8 out of 10 as an experience is what I would say. So the next thing that I was looking into was getting into a proper team which is of larger size and has more experienced players in the team who are into the security researcher kind of role, so that I would be able to have more exposure and more knowledge that I can derive from these guys, and maybe because that is what I had lacking in the last role. So is what I'm currently looking for right now.
Yeah,
I
thanks for
feel
that.
like this was a corporate interview, the HR round.
No, actually, no. I just wanted to ask about that. Yeah, how do you feel? So that's fine. So yeah, so that answered my question. So anybody have any questions so they can
Okay,
ask?
okay, Sudhakar, what do you think about freelancing as a security guy? Do you ever think about working as a bug bounty hunter or independent security consultant? What do you think about that?
So as I told in my last discussion, just last line, that yeah, the this is like a roller coaster. Sometimes you get it, sometimes you don't. So I won't consider being a full-time bug bounty hunter in this sphere because the bugs are not that permanent and the target is pretty specific. Now, in case of a web bug bounty, I could definitely, if I knew web, I would definitely take it up because the number of targets is not that small, and people are also like, you can say, yeah, matlab, although the people attacking the target is pretty great, but the targets change very frequently. Very frequently, you get new programs into your bug bounty circle. You get private programs, and also if you're trying to target a web-based bug bounty program, I can say you can definitely go for it. But even I know like 10 15 people who do it full time and they have a pretty good pay and like that. So but after some time you will want stability. Let's say you want to get married or something like that. for your family's sake, and also eventually they also switched to proper security-based roles in product-based companies in the program sometimes that they were working on a web bug bounty.
Okay.
Yeah, but the bounty payout part is quite a good incentive that you can give it a try at least for like 6 to 10 to 12 months, something like that.
I think the last one was the last okay was Mrugang's frustration and sadness.
Yeah.
Cool. Any more questions? Yeah, I guess that's it. Okay, we are kind of reaching the 1 hour mark. So I guess that was it. If no one has any more questions, yeah, I guess no one has it. So thank you, Sudhakar. This was great.
Thanks, guys. Yeah. Great to be here.
How was it for you, Sudhakar?
Yeah. Good night.
Good night, everyone.
Bye.
Bye bye.